All right, welcome, welcome, welcome. I'm Chris Gorman. I work at the Center for Educational Innovation, and my role there focuses on supporting teaching and learning in STEM disciplines. Today's discussion is part of a series of discussions designed to bring together folks teaching courses with experiential components. And of course, today's discussion will be focused on science labs, which I know means a few different things to the folks in this room, but we'll kind of touch on a few different aspects of that. I will be recording this session and then also consolidating notes from this session and the session last week, both what's verbally presented here during this session and also what's exchanged in the chat. And we're doing this in part so that we can share all the good ideas and resources that are shared here broadly with the university community, but also so that you have one that you can come back to. Well, about a third of you are probably teaching this summer. About 2/3 of you, as we talked about before, are preparing for a undesirable situation. And so you might come back to this again in a month or more. So a big thank you to Barbara Beers and Walker, who are colleagues of mine at CEI, who are helping me to monitor the chat and to take notes. And let's see here. And I mentioned this before, but as we get started here, make sure that you can find the participants window and the chat window. The icons are either at the top or the bottom of your screen. And if my slides are taking up too much of your space, just hit the escape button and then they'll get small and there will be space for everything. So as I mentioned, this group teaches a few different things. Chemistry, anatomy, biology, kinesiology, neuroscience, earth science, plant pathology, physics are a few of the big buckets, although there are those of you from some other disciplines as well. And if you don't mind, just go ahead and introduce yourself in the chat. This can help you guys to connect with one another, people who are teaching maybe similar things or in departments on different campuses. We have people joining us from all 5 of our system campuses today. And one of the cool things, right, about doing online programming is that it's so much easier for all of us to connect. So as you're introducing yourself in the chat, some of our 2 main goals for today are to share some ideas from folks who have taught online before, who have taught science labs online before. And then the other is to problem solve, especially for those of you who are teaching in the summer. We want to make sure that maybe you've got an opportunity to propose something that you're struggling with as you're starting to think about or are getting into the final planning for your labs, and pitch them to the group and see what kinds of ideas others may have for those challenges. So we'll start with sharing from some of the folks who have done this before, Pete Border and Charlotte Romaine, and if Beverly wants to jump in, she can. Just tell us a little bit about their experience teaching online, and then we'll switch it over to kind of that problem solving mode where we'll kind of pitch questions to one another and challenges.
Okay, I teach.
Oh wait, I'm going to do one other thing first though. And then our Zoom tools for today is that ask questions in the chat panel. So you can ask your questions, you can respond to questions there. I'll try to bring those forward into the verbal discussion because I know monitoring both can be hard. And if you want to talk just to help me with the traffic control, if you can raise your hand, which you'll find the button in your participants window, which is why I asked you to open that one. You'll see the far left-hand button there says raise hand, and you can click that and it makes you pop right to the top of my list. So it makes it very simple. And then with no further ado, I am going to turn it over. My list is out of date, but Pete and Charlotte are joining us today. And Pete is going to get us started teaching physics.
Okay, I've been teaching two online physics courses. They're freshman physics, and there's one in the fall, one in the spring. In the fall, we talk about mechanics and things moving, energy, momentum, that sort of stuff. And then in the spring, we have a class that goes through all sorts of things, oscillations and temperature and heat and a little bit of electromechanics. So yeah, there's a lab component, and the way my courses work is that students get a list of things from Amazon, and they purchase things from Amazon, and that way, first off, getting all that stuff is Amazon's problem, not mine. And you know, if I want to change it, I just send out a different list and I can revamp the entire thing right up to the night the email goes out, which has turned out to be pretty handy and sometimes.
Hey, Pete, can you hear me?
Yeah.
Hey, so I don't know what had happened the other day, but I didn't hear what someone had said about this is Joseph Chastel, biologist,
Okay.
professor at Crookston, um, about liability issues about conducting experiments at home. Are you ever concerned about that? Because we have mixed feelings on the Crookston campus. We're not really sure how to proceed with that.
No, I have never even looked into that. The things we have are harmless. They're like little toy cars and Nerf guns and so on. And it's very hard to imagine how anyone could hurt themselves with it.
The big concerns that we heard, and we can return to this after Pete tells us a little bit more about his as well, is that the big concerns about having things at home in terms of liability, if you have self-bought kits, is just around disposal and hazardous materials. And so I'll include a link in the notes to the department on our campus, DEHS, who has been fielding questions for departments who are concerned about that and can help you to navigate some of the issues.
Thank you.
Mm-hmm.
Okay.
Go ahead, Pete. Sorry.
Anyway, all right. So that's the way we handle this. The experiments they do are things I cooked up that can be done at home. The big constraint really is the cost of the kit. That's a huge issue because you really want to keep that as low as possible. And you know, part of the way that works is that the kit includes a lot of things that students will be able to use in their normal lives, like little thermos jars, you know, and it's like, sure, this has a use after the class is over. It's not like you're stuck with a bunch of test tubes or something. So, you know, we've been doing it this way for several years, like 10, I think, I don't know. And it has worked. Students enjoy it. They really like the fact that they can do science experiments with stuff from Amazon and things lying around their kitchen. You know, it's interesting. We have labs that use laser pointers and people use cat toys. It's kind of, you know, whatever you have that's a laser pointer. Another nice thing about using Amazon is if they already have something, they don't need to buy another one. And you're not forcing them into purchasing some sort of kit. They're free to share if they have friends. That's totally okay, and you just want to buy one, that's fine.
Pete, can you tell us a little bit about the activities that they engage in and how they collect data?
How they collect data. Well, a lot of the activities in the spring course are things like write down the temperature every 10 minutes. So they buy a thermometer and they do exactly that. Things in the spring and the fall when things are moving, that really requires you to have some way to measure something rapidly. And if I was doing it now, I would use a phone camera, and there's some free software to analyze it called Tracker, which works really well. But the way it works, it does work, is that they use audio, and by setting up an experiment so that when events occur, it makes a noise. You can record that with a simple microphone, costs $10, and then there's some free software to analyze that. So you can figure out what time something happened from a recording, and that actually works surprisingly well. The other things they do are, you know, spin a wheel and listen to it slowing down. again, you use audio to measure it. It's a neat trick. So the data taking is trying to get as much out of a computer as possible. If they're taking an online course, they obviously have a computer, and using free software to analyze it. And I don't know, it works pretty well. I'm actually quite happy with it.
Cool.
So I would have changed over to video, except you need a good camera, you know, you need a camera that isn't blurry. And that means it's probably expensive. And once again, you're back to forcing them to buy some expensive equipment, which is not a good idea. A microphone is cheap and works with, you know, just any computer. So, yeah, it took a lot of thought to figure out how to do this stuff. And it is not easy to come up with experiments you can do at home, but it can be done, at least in my business. I mean, other people clearly have a whole different set of problems, and I'm sorry I can't help you with that, but this is what I did, and they actually like it. When I meet some of these people on the street, they know who I am, because there's loads of video that goes with this. I mean, I did all the experiments in front of a camera, so they know who I am. I have no idea who they are. And they say the funnest part of the course was the labs. It was really fun to have this stuff in your home and figure out how to make a physics lab out of it. And okay, good. They were fun for me too. I love doing labs. So that's kind of my story of online labs. It's hard to figure it out, but it worked for me anyway. So, okay, I'm done.
Any questions for Pete? And then I'll go to the next on my queue. And you can raise your hand or toss it into the chat. All right, I'm going to turn it over to Charlotte, who has been teaching flipped labs and then converted some of those to online this spring. Are you still there? Oh yeah, there you go. Go ahead.
Sorry, I just had to unmute. Yeah, so we, in the medical lab science program, we've been doing a flipped format for a while. We do have a lot of labs that we do on campus, but we do some flipped stuff. And so we have videos online in the Canvas site, and we have lab simulation type things on the lab site. Some of them that I've just found, and some of them that we've made ourselves. This spring, when we had to go to completely online, we did a few kitchen type chemistry experiments in my lab. So we do the beginning DNA extraction and PCR, electrophoresis, chromatography. Mine is kind of the fundamental medical lab science course, where we go through all of the different techniques that are used in the clinical lab. And so I asked them to go home and do a DNA extraction with whatever they could find in their kitchen. And so I asked them to think through, you know, what are we doing in a DNA extraction? What do I have that I can use at home? And then I asked them to do a Flipgrid video and show us their result and talk us through their process and why they decided on the things they decided to use. And it was really fun to see the videos. They were very creative. And, you know, not everyone had the best things. Not everyone had some isopropyl alcohol at home. I know one student used 120 proof rum. So it was fun to see how they troubleshooted those things and to see them thinking through the problems. I also asked them to do a chromatography lab the same way. What do you have in your house that you could use for solid support, you know, the liquid portion? What things could you separate out, think it through? And I asked them to do another Flipgrid video, and those turned out really well.
Charlotte, there's some questions in the chat kind of talking a little bit about how you used Flipgrid and what Flipgrid is. I'll give the quick primer on what Flipgrid is, which is it's a software tool that is web-based, where you can create a grid by which people can participate by submitting a video, which is time limited. They have to be less than 10 minutes, but you can actually set short limits on it. So 1 minute, 3 minutes, 5 minutes. And then you have someone seed the grid, and then other people can reply. So you can either do it for everybody doing the same thing or for one student to submit and then reply to one another. And Catherine Kirkpatrick has linked a nice link there for it. And it's actually homegrown out of the U.
Yep. Yeah, so it's a university program, and so we all have access to it, and it's integrated into Canvas. So you can do that integration, and then Flipgrid will be right in Canvas. You can make the assignments from Canvas. So that kind of makes it easy.
How many students do you have using Canvas? Sorry, using Flipgrid, I meant to say, sorry.
I'm sorry?
How many students do you have using Flipgrid?
So I've used it in several different classes. Right now, my course has 18 students in it, but I have had 40 students in a class using it. I also use it for introduction videos, like at the beginning of the semester, and things like that.
All right. Anything else that you wanted to share? Any questions we've got for Charlotte so far? One of the things I thought was interesting that you shared last week was the ingenuity of the students, not only around the room, but also in what kinds of things they chose to extract DNA from, and then what they did with the differences in their challenges.
Yeah. So yeah, it was just fun to see how they did it. Some chose fruit, a couple chose vegetables, one person decided to try hamburger. And then at the end, if they did or didn't get DNA, they all just discussed what they thought happened in the experiment. And I gave pretty loose guidelines for doing this because it was all just kind of on the fly. And so I was really happy to see that they were like troubleshooting, as they were going along and saying, well, I think next time I would do this. And a couple students did it twice and validated their theory and made another Flipgrid video to show their second time. And so I think they were pretty engaged with it. Yeah.
Yeah, I'm just going to take a minute here too to kind of highlight that element of trial and error. So Charlie Willis, who presented last week, who couldn't come today, also has a series of online biology labs for a course offered from the Twin Cities campus. And he was describing and talking about, he's got a few different labs, one which is a 5-week lab where they grow UV sensitive yeast and then test the efficacy of various UV protective products, that expecting students to have some trouble and expecting some failure and then having a plan for what you're going to do when they have difficulty doing the lab is actually quite important. And so Pete's got a way that he does this, but it also, Charlie has in his class that he has students submitting videos of the setup as they go, so you can check that things are actually moving along. And then also that if, they have an epic failure, that they're that he asks them to provide 2 data graphs, so a chart or a depiction or a set of data of what they think should have happened and what maybe did happen in their situation. And so there's a sense that can they think through what kind of data would have supported their hypothesis and which kind of data would have rejected their hypothesis, and then also making a bit of sense of why their experiment didn't work. In some cases, it's because the Petri dish fell on the floor and the yeast then didn't culture in time or something like this, but having thoughts on how you're gonna handle that. And Pete's got a way in which he handles failure in his class, which maybe now might be a nice time to share too in light of all this.
I make sure that every lab, my labs are only a week long, so they don't have 5 weeks to do things again, basically. So every lab, there's video of me. Well, my students are only freshmen, so, there's a limit. But there's video of me doing the lab, and then the data that I got doing the lab is available to them. So here's what I got, and if they absolutely just cannot get the lab to work for some reason, which isn't surprising, the labs in the day school, there's people who take care of it, there are TAs around to make it work right, and none of that is available at home. So if they just can't get it to work, then they're allowed to analyze the supplied data, and they can still do something about it. They can get some sort of experience with it. And also make sure that in their lab reports, the last section is about what went wrong, what could you do better, what would you do differently next time? And this makes them think about it, which is the whole point of doing a lab. You have these principles you learned in the classroom, and here's what the real world is like. So it's I think it's an important part of doing, especially a lab at home. You have to have some sort of backup, because they will fail. That's just the way it is.
We use data sets as well, because we do a lot of work with the students running controls and you know, statistical data and looking at whether or not patient samples can be reported out based on what the run looks like. And so we use data sets as well, and we throw in things that are abnormal and have the students analyze that and send that back, or analyzing a Western blot or analyzing a gel. So you can give them pictures of gels and say what was in each well and have them label it and analyze the results.
Yeah, that's a great thing to do. Frankly, I wish they did it in the regular labs. Seems like here's some good data. Tell me why it isn't like yours. You know, this is.
The more I talk to folks who do at-home labs, the more I realize that there's actually some advantage to having students have slightly different setups and having slightly different results. When you write about the what would you do differently next time in a traditional lab setting, sometimes it feels very pro forma, but these at-home labs really provide opportunity for having real reflection on how the techniques or approaches could be different. I now want to turn to Joseph Schostel up at the Crookston campus, who also has an online biology lab. Do you mind just sharing a bit about what that looks like?
Yeah, I mean, pull it up or just talk about it.
Just give me the maybe 5 to 10 minute short story of it.
Okay,
whatever way you want. If you want to share your screen, go ahead.
Yeah, okay, so this is Joseph. Sorry when I asked that question earlier, Pete. I had to leave that meeting earlier last time. Yeah, so like all of us, we are enduring during this, but what we decided to do here is to try some simulation labs through a company called Labster. And I hadn't used these before. Basically what it is, it's you know, it's kind of like that gaming mentality where students access a particular topic, and when they do the simulation, it kind of gives a Star Trek kind of appearance when the students get involved in it, and you talk to the computer, and well, it speaks to you, and you can communicate with it via the keyboard, and you can also control levers and so on in front of you, almost like you're playing a game. And it takes you through some kind of a case study, and it has you set up an experiment in some cases, and you can pretty much do everything, but it's just remote. Set up hypotheses, take a look at the data, understand graphing, and then it asks a series of questions, and you proceed through this, and if you answer something incorrectly, that while doing the simulation, it lets you know, and it will quiz you again on that, and you can proceed through this. And so what I've done, these aren't, to me, in my mind, they're not an exact replacement of a physical in-person lab, but they are lab-like, and I consider them preferable to nothing. And I've been actually quite impressed, because usually what I do is I set them up as you can do them as many times as you want, and I find some students going back and doing these again and again, and I usually set it up as they can earn X number of points on that, and I let them max it out. And so so basically I can go back into Labster and find out how many times they've done it, the score in each one of those, and if they've improved along the way, and then I can follow up with my own questions. It's not perfect, but let me stop there first to see if there are any questions on that before I continue. There are some,
labs. I do have a question, Joseph.
Yeah.
Is that Labster? Is that something that is free, or is it something that is
No.
supported by the youth?
no, neither. It's not free. It's not. We've had some issues that it's basically it's ended up to be it's sort of a la carte. You can choose through the labs that they have, and they have, I don't know, I'm just going to guess 125 labs or so. And you can choose if you're doing molecular techniques course, or if you're doing ecology, if you're doing physiology. There's a set of labs that you can look in those areas, or you can span across all of those and do that. So what we ended up doing is we picked up. I was already doing a Biology 1000 class, and that was completely online. It was the first time that I did one like that here at University of Minnesota. So I already had one foot in there already, just trying it out to see how well I liked it. And they charged us $85 per student for those 10 labs. So when we all transitioned our other courses to this, since I already knew about that, I went and talked to Labster about the possibility of converting another course, which is the Biology 1009 class, which is intended for science majors. And in that case, we chose 5 labs, and didn't matter in terms of prices if we had elected to use 1 or 5, it was all going to be the same. And then we partnered up with the other professors on our campus that also want to do some simulations. So we all went in and then got a price for that. I don't remember what the price was for that. But then, given that we were in a predicament, and we did a little bit of haggling, they then said, well, we're just going to open up all of our labs for you to use. Of course, they let us know after we had made our selection that we're going to, the labs that we wanted. But what was nice about this is that allowed individual professors and students just to kind of, go in and check the ones you wanted to see. And so I'm already thinking, excuse me, if I choose this in the future, what are the labs I might try? Because now I'll spend the time, and students are providing critical comments to me. One issue that I did find, though, supposedly it connects well with Angel. If you're doing grading on Angel, we've had issues with that, and it hasn't worked for us yet, and I'm not quite sure why. But that it's not like, for those of you who use Connect and so on, where it's automatically integrated to your Canvas platform. So that's another step that you would have to do, and go directly into Labster, pull those assignment grades out, and then put them individually into your Canvas. I do think that that's going to be rectified, but it hasn't been yet at this point.
Thanks so much, Joe.
Sure.
Do you have students work in groups at all in your labs?
Not in this case. What I do is so not for the simulation pieces, but every Tuesday, I would still meet with those students online, and then I would give them a kind of a show and tell of that particular lab, show them how to go into it, what it means, and just take the broader questions and try to relate it to what's going on. And then take the questions from those students, and we meet very briefly, no more than a half an hour. And then if there are no more questions, we would end, and then they would then take it away from there. And everything else would just be probably individually between myself and individual students.
Great. So I want to, oops, sorry, I muted myself there. What I want to do is see if there are any kind of specific questions for kind of Pete, Charlotte, Joseph, or if folks want to ask more about Charlie's biology labs, I'd be happy to attempt to answer those questions. And I'll just wait a second to see if there are any hands or questions in the chat. Did I miss anything?
There was one about what percentage of the course. Jane Wissinger asked what percentage of the course that, was it Charlotte now, who was using with Labster? Oh, sorry, Joseph, sorry.
Labster, yeah.
Yeah, sorry. I just looked at my screen here, yeah.
Great. What percentage of
Question?
labs are you doing using the simulations?
For which, it depends on for which class. If it's for the Biology 1000 class, which is a science class for non-science majors, it's all of the labs. In the past, another professor had used lab kits, but I didn't feel comfortable doing that, again, because of liability issues. I want to read more about what other people had said about that. the idea of having a series of reagents being delivered to a household. It just seems rough with potential issues there. Um, and then, but for the Biology 1009, that's the one that had transitioned this semester. And so it was about the last 5 labs. So we had, you know, the semester goes 16 weeks. So we had already passed the halfway point where we actually met in person. And that, by the way, in our 1009 class, we have pod stations, and it's very common for students, and because of how the room is set up, it sits exactly 16. And the students usually work in groups of 4. And they do that throughout the semester on some projects, which are that they start and finish on the same day, and others go across several weeks. So it was certainly a break from that team approach to the simulation.
Thanks, Joseph.
I just want to say about simulations in the physics business anyway, that it's very easy to build them so they don't work right. And I've got a class now which has been moved online, and we have been using simulated labs because it's what's available. And quite a few of the things online just, you know, they don't work right. One this week turned out to have a crucial sign error, and a beam of electrons was getting deflected the wrong way. What can we do about it? Nothing. It's not ours, you know. You can send nasty emails to the people who wrote it, but it's free and you get what you pay for. So anyway, there's a word to the wise. I had to learn that one the hard way.
I would just add to that I completely agree. We really feel like guinea pigs this first time around. But having said that, I think it's and it takes extra time. Of course, in the case of Labster, we're paying up front for that. Reviewing that ahead of time and actually catching things and telling them over to the software engineers of those companies is certainly important. But it is an extra step. But you know, having said that, we all look at our stuff beforehand before we teach, before we do experiments, to kind of to troubleshoot that ahead of time. So I don't really think of that really as anything different, except that if there's an electronic issue, and then if you're not trained as a software engineer, you don't have the means, capability to change that yourself. And if that company, whoever you're working with, isn't willing to assist in that, then that's a deal breaker.
So now I kind of want to turn it over and turn it into the kind of problem solving portion of this lab. I also know that there's a set of folks who have a lab that is very different from the ones described. And so I want to allow any of them, if they want to kind of bring forward any of those challenges. So I invite you, if you have kind of something maybe that you're thinking about, or a challenge as you're starting to plan for your lab, either this summer or the potential for the fall, if you want to pitch your challenge to this WISE group, go ahead and raise your hand, or if you want to try and put it into the chat, I'll be happy to do my best to read what I assume will include jargon. And then I'll come back to a couple more questions about these simulated labs. So Lisa asks Joseph if you could give an example of something that they're doing during using Labster. So what's the kind of student activity that they are engaged with, and how does that work?
Okay. What I'm going to do is I'm going to send a link, and then people can explore that. I just saw that in the chat. I just was pulling it up, and I was going to see if I could pull down a series of labs which people might have an interest in, and then I'll send the general link, and you can kind of explore it from there. The topics are so varied, and so all I can speak to is that you know, think of it as a case study that's broken down with experiments inside of it, and students have time to explore what that is and go through. If, for example, if it's Mendelian genetics, they can think about potential crossing and what it would mean, and they would be asked questions before the experiment, and then they can think about possible data that would be collected from that, and then do the experiment so they actually there are some hands there in front of you that are your hands through the screen, and you individually grab a mouse, another mouse, you put them together, and they breed together. They have offspring that you can see the characteristics that their coats have, and then again they're predicting in their minds about possibilities about the next generation, and then they could fill out something as simple as the Punnett squares and so on, and build up from there. So what you do with that, I find, on my end, is that just with all information is to give it some greater context. There's quite a bit that's provided within Labster itself, but certainly on the professorial side is to add and link it to broader things if there are limitations in the particular experiments within that. So, but what I'll do is I'm going to send a link, and I'm pulling it up right now. So hopefully that answers that question.
Perfect. Here's one that I want to throw out to the whole group, especially those who have been trying it this semester. And then I'll also toss in some ideas from Charlie from last week. Catherine Kirkpatrick asks in the chat, I'm interested in strategies for facilitating online group work for lab and research projects. For many of us, I think lab is a place where we try to facilitate group interaction and we try to facilitate teamwork skills. And there's important learning objectives that we don't want to lose by having our labs online. That's me editorializing her comment. But one of the things, I know that some of the folks here haven't been using group work, but as I mentioned, Charlie Willis does use group work in his online biology lab, which involves also an inquiry element where they design their own experiments and then work together as a team to collect data. And the way that that works is he has a lot of clear expectations with the students where they that group work is an important element of the class, that he wants them to introduce themselves. They do some Flipgrid introductions. They do some other sort of collaborative kind of getting to know you activities, but then they're required to coordinate through asynchronous discussion forums to figure out how they want to design their experiment and how they'll implement it. So in some cases, they do control and replications, or in other situations, they each do a portion of it, and then they have to come up with how it is that they will come together to just how it's going to be executed. So is it going to be multiple people doing the same thing? Is it going to be different people doing different things? And then be able to come together to talk about what that data means and how much confidence they can have in it, given the experimental setup that they chose across multiple people, across multiple sites. So that's one model. I wonder if there are others here who'd be willing to share other ideas or models for group work in an online setting.
Chris, I can jump in here. You had asked me earlier, just Beverly, if you wanted me to talk a little bit about that. Even, one of the things is really thinking about that level of student, but also how important that collaborative connection is, and having some backups for those who, obviously, as we've seen with COVID, if somebody gets sick or if somebody's just overwhelmed, it's been really good to connect students in groups of 4 to maybe have some backups in case somebody does disappear. I've also just used Google Docs as a way for them to see each other and to post questions, and also to try to have them using, the Canvas platform or the Google Doc forum, so that it limits some of the email flow and also really helps the questions coming through that collaborative feeling. I've had some students act as a mediator or a moderator each week who then help guide the other students. I just post a really long posting in here thinking about some of the, I'm teaching or have taught online biochem labs hybrid. I've done some chemistry, I've done physiology, anatomy, I've done introductory level type stuff. I'm challenged right now with the biochemistry aspect, and as an administrator, I pulled the plug on some microbiology labs that were being done online at home, because that's where that safety issue comes in. If people are isolating, say, from hamburger meat a microbe, then it could be salmonella and something toxic. So we've been, I've looked a lot at the safety issues, but some of these easier ones, like the eggs and the osmosis, you can take those really easy, thinking about dissolving the shell in vinegars. It's like a 7th grade lab, but you can turn it into an introductory college lab. And the DNA and isolation of bananas and all that, different fruits. And I think the key thing that Pete and Charlotte, Joseph too, have all mentioned really is that inquiry aspect of it. I'm struggling. I have partnered some of that with HHMI virtual labs, so they get a feeling for how the lab, so there's a really good one with DNA lysis, and then they take it to DNA fingerprinting. But I'm struggling at this level of how to do biochemistry labs that really high-end, high-tech. Most of them have been in the research lab. Most of them are really wanting that hardcore biochem level. We have gels and data that we're providing, and they're analyzing that. So if anybody has ideas on that end, we had been very fortunate that we videotaped all this last year. So I actually have videotape that's going into modules, but, and I love the idea of Flipgrid, but just if anybody else has other ideas for that biochem level, and if anybody needs ideas for micro or bio or any of these others, I'm willing to give ideas.
And we have thoughts for Beverly on kind of these higher order labs where there's more technical equipment and higher order work. Anybody want to chime in? Even if it's half baked, we're all looking for ideas here. No bad ideas.
Hi there. So I had a question about the microbiology aspect. We deal with plants for the most part, so this maybe some of the safety concerns are not quite as the same as for human pathogens and things. I've been curious about some of these relatively inexpensive digital microscopes that potentially students could use. I don't know if you've had any experience with that. If anybody has had any success with that at all, I'd be interested in knowing about that.
We actually had put together some lab kits at one point where we test drove some different smaller microscopes that we could sell to students. We were really concerned with the cost, what students would buy in a lab kit. And there are companies that offer these, and they offer, some of them will offer also a $2 million liability policy with them. There's a reason they offer a $2 million liability option. Some of the stuff that was being asked to do at home has some concerns. Some of the microscopes we looked at did not have the power magnification that needed to happen for really seeing like gram stains and things like that. We put together some of our own lab kits, very simple little things, but even then being shipped to other parts of the world. There are some of our students who sometimes, the ones that I taught previously were all around the world, so Amazon didn't always get it to them. Bookstore were some options, but bookstore also didn't always get in. There are some shipping barriers when you cross borders, so if any of your students are out of the country, there are some issues that way. But one of the things that really was successful, and even you guys have mentioned, having them think about what ethanol they used. Charlotte mentioned that ethanol, thinking about the proof with the concentrations. There's lots of really great stuff that can be pulled together. I actually spent about 8 years pulling together a bunch of these ideas. I've never written them up. I've never published them. I'm really just, I'd love to do that in May if I have time, but I have to design a biochem lab. So.
The only microscope that I'm familiar with is that I've had some biology faculty I've worked with try out what they described to me as the $19 cardboard microscope, which is using your phone with a set of lenses that get shipped to the students, which they assemble into essentially a cardboard and lenses sort of microscope. And again, you just need to check the power on it. I also know that same concept was actually an intro engineering project over in CSC 1 year to create these kinds of things and design how you could do them in order to look at things. So I do know that there are some low cost, and then of course looking into the power for the kinds of things you want to do. This is going back and forth as well in the chat between Aaron Serto about using cell phone cameras as spectrophotometers, and Jacob Wayman says that they work fine for lower division chemistry videos, and depending on what you want them to do, then you can find out if they're good or not. I want to make sure that we come to one other kind of lab that was floating around in the registration questions, and I just want to see what folks are thinking about doing. And I think even if you have a half-baked idea, sharing it with the group would be useful. Is there's a set of you who are concerned about dissections. So I think it was about 5 or 7 of the folks in this session have plans. Their typical lab involves some sort of dissection, either entomology or an anatomy or differing kinds of dissections. And I'm curious if anyone would be willing to offer what they're kind of thinking about, if those dissections then need to be, or the labs that typically involve dissection would go online. Would anyone be willing to share what they're thinking, or are we also?
This is Lisa. I don't teach anatomy, but I have colleagues that do, and the anatomy lab has been quite a challenge, but one graduate student videotaped, where two graduate students worked together, and this was, you know, a human cadaver, videotaped dissections and videotaped finished dissections and put together videos and resources for the students. I think it was better than, this is going to sound terrible, it was better than nothing, but it, you know, it was not always clear what the structure was, or so, you know, there have been some problems, though I think, you know, they did, you know, I think they ended up doing a great job considering all the difficulties. But essentially what the faculty are doing now are there's something called the visible body and some other software, and they're looking into those kinds of things. Just because making our own videos it was less than desirable. So I don't have I don't have a rosy story to share, but it's tough getting visual quality that the students could actually learn from the structures. I think the students did learn, but you know, it wasn't optimal. I don't remember the name of the virtual lab I used at the time. It was only came on CD-ROM. This is maybe 5 years ago. It's an anatomy virtual lab. So there are some really good ones where they peel back the layers so you can see the 3D, and then they peel back the layers. You can see all the origins, insertions, and the different levels of the musculature. But because it was CD-ROM, it was limited. And so they're probably doing that web-based at this point. I'm out of touch with that as well, but I'm sure somebody can find one of those. It was really well done. And also we had students doing clay at home. So they just got some clay, and then they built the models themselves with the origins, insertions, or thinking about where certain anatomical parts were found that way.
All right, let me just, what other questions or what other challenges are folks came here hoping to hear what others are trying and what they're doing?
There's a question online several people are talking about with Jove, and I know they're free until the 15th, but we're asking the question, does the U have any access to that?
The Twin Cities campus definitely does, and I've directed people there before, but Jacob's saying that up on the Duluth campus that those are not the same, that they don't have access following the free period.
Yeah, they Jove has been contacting us a lot, like prior to the quarantine. Jove contacted several faculty in SCSE up here, trying to prod our library to actually get a subscription, and now all of this happened. And so I know several chemistry faculty up here are really interested because their general chemistry videos are quite good. We're teaching summer quantitative analysis, and so that instructor is really interested. And the June 15th timeline is about halfway through our summer session. So we've got some people planning to use it at least in part this summer, but then we're going to lose access, and then we don't have that option anymore. So we're trying to nudge our library a little bit, at least those of us in chemistry who are doing this.
Great, thanks for that.
When I looked at them about a year ago, they didn't have the Highness Level for some of the things I wanted to do. So they're a growing library. So that would be another consideration for people who are considering Jove.
And our biochemistry, I'm teaching a biochemistry lecture this spring, and the instructor who was in charge of the lab component, she used their Jove's videos for the biochem lab, and it was quite good for upper level things like enzyme kinetics and things like that. So the combination of their videos plus data from previous semesters ended up getting them through the end of the spring.
And kind of as we wrap up and kind of come to a close, what I want to do too is bring in some of the other things that have come up in discussions, both about science labs and programming labs and field experiences and all of these things in STEM fields that are really experiential. One of the things that I think was really kind of worth noting yesterday in a field experience was Sue Galadowicz, who teaches in fisheries, wildlife, and resource management, shared about teaching a field experience online, and that the process of figuring out how to put essentially a field experience where typically they go into to a field station and look at the surroundings and take measurements is really overwhelming at first to think about how you might put that into an online space. And when she created the online course, that she spent the first part of it really considering her learning objectives and thinking about which of these learning objectives are best met through a quick didactic, which learning objectives are most appropriately and competencies can be done through pinning on a map in her case. And then which of those learning objectives are really psychomotor? And so which ones are the ones where they want access to drawing or to practice doing certain kinds of skills? And that when thinking about her field experience in the online space, thinking about how to separate some of the learning objectives which are typically tethered. So typically taking a measurement in the field and developing drawing skills are the same activity. But in her case, what she'll do is have them be separate activities whereby they do the kind of taking measurements or doing observations through the virtual field site, but then they'll do drawings that are in their homes or in their local environment, or taking measurements of buildings was another idea that was tossed in that session. And so the other thing I just kind of want to put into this session as people are thinking about how they're going to transition labs and in situations that feel really challenging is thinking about which of your learning objectives could be accomplished not by doing what they typically do in lab, but maybe still working towards those motor skills that you want them to develop, but potentially in a slightly different task that's now untethered from the typical lab activity. And I thought it was a really interesting way to think about both the challenge and the opportunity of the online lab. So with that, what I want to do is two things before we close out. First is to ask you if you are interested in continuing some contact with this group as the summer progresses. If you're interested with a general science lab kind of group, if you're interested in maybe additional discussions with smaller, more disciplinary specific groups, if you click that second one, let me know what those disciplines are so that I can kind of get a sense for which groups. Or if you'd like me to set up a Google group, I'll actually give you the spoiler on that one. I'm already going to do it, and you can sign into it where as people find resources or have questions or challenges that you guys can email one another and get in touch. It'd be really helpful to me to know whether how we can help support you in this as well. And again, if it looks like there are a number of people interested in smaller disciplinary specific groups, if I can help you find those groups, or if you can tell me what a reasonable scope would be, that would be really helpful as well. As I'm seeing quite a bit of interest, just drop it into the chat. And then finally, I have one final request. We're doing quite a number of these, and I'm going to ask Walker to drop the link, but we're doing quite a number of these, and it would be great to know how we're doing, facilitating these kinds of discussions as well. So he's going to toss a link to the chat. It's z.umn.edu/sciencelab2. Looks like. And there's a link there. You can't obviously click on it anymore due to the new Zoom security protocol, but you can copy it and paste it out. And so that would be really helpful as well. So if you want to let me know what kinds of small disciplinary groups, I'm happy to stick around with folks to answer questions or kind of think as we finish it out. Otherwise, I will leave it to you all to complete the eval and connect with one another as you see fit here.